Alright guys, today we're going to pick up right where we left off last time with dissolving our sugar cubes in water. So I'm going to flip our camera around and let's look at our lab journal. Alright. Now, remember yesterday we completed the mixing it up part 1, questions 1 through 5. And today we're going to look at questions 6 through 10. So question 6 says, observe the crushed cube in water for 2 minutes and record your observations. So to crush our cube, we're going to use this tool, which is called a mortar, which is this half, and a pestle, which is this half. This type of tool is extremely old. Civilizations have been using mortar and pestles for thousands of years. They work really well to grind up. You can grind up rocks or minerals. You can grind up herbs. You can grind up medicine. These have been very, very useful for a lot of different civilizations. And we're going to use one today. So what we're going to do first, just like yesterday, we are dissolving sugar into 100 milliliters of water. But every time we run the experiment again, we change up one thing, or we change one variable about it. So the variable we're changing today is originally the very first one, we used a whole sugar cube in water. Well, this time we are going to crush this sugar cube up in this mortar pestle. And then we are going to observe the powder and how it dissolves just in water from the crushed sugar cube. So I put my cube in. First thing, I gotta knock it up. See it coming apart there? Right, so now I'm getting some smaller chunks. And once they get a little bit, now I can just start swirling. And what's happening is this end is pushing down and crushing the particles against the bowl. So I can push, and it's not really difficult, but it's not just easy. It takes a little muscle. Taking a little effort. So now we got them crowned up. Now we can just kind of stir it. You can hear those pieces grinding. We can do this. We could do this for a really long time until this sugar cube is crushed down and the particles are crushed and crushed and crushed until they are just pulverized into a powder. Now we don't need it that fine of a powder, so that should be good. All right, now let's adjust our camera here. Come down. I'm going to take my water. I'm going to put in 100 milliliters. So that's about 50 milliliters. So a little bit more. All right, that's got us. So we have, let me get my science journal out of the way. So we have 100 milliliters of water in here. Our camera set at an optimal viewing angle, and we are going to put this in. We're going to put the water in and observe it for 2 minutes. And remember, our paper says observe the crushed cube in the water for 2 minutes, record your observations below. So while we're doing the 2-minute observation, we can make notes, we can write things in our journal, talking about what we observe, what we see as it's happening. Slide you a little closer here. Okay, so we're going to start our 2 minutes. Get our powder round up, and we can begin. So you can already tell it's dissolving faster than the cube was by itself. So we're just watching this. We're about 20 seconds in. What do you see? Think about it. Do you see particles? Do you not see particles? That is an observation, whether we see something or not. Man, so that water looks very clear, doesn't it? All right, and that's 2 minutes. So let's take a look from the top down, just so we can look from all angles. So we can see there's still a little bit of sugar in there. You can see all that kind of fuzzy, but that is really not much at all. Not much at all. All right, so let's go back to our journal. Set these aside. And let's bring our journal back in. And let's look at number 6 up here. So, what kind of observations did we see? So you can write anything you noticed here. Did the water change? Did the sugar cube, or did the sugar change? Did it dissolve fast? Dissolve slow? So go ahead and write down some observations you have. What did you notice? You can back the video up if you want to look at it again, to make your observations again. But right here, you want to just tell me exactly what you saw. Did the sugar change? How? Did the water change? How or how not? All right, so for now, I can say sugar sank and began dissolving immediately. Okay? Now number 7, compare your observation of how the sugar cube dissolved when it was whole and when it was crushed. Was there a difference in how much of the sugar cube dissolved? Why do you think this is true? So now we're going to compare the crushed sugar cube and how quickly it dissolved, and we're going to compare that to the very first sugar cube we did, and compare and contrast how what they did similar, what they did different. So if we look back over, so right here we're just going to review what we observed and previously. So this was for the very first experiment where we did 2 minutes of a whole sugar cube. So at first there was no change. Particles broke away from top of cube. Cube changed shape from particles breaking away. Now let's think if any of those apply over here. So with the cube, at first no change. So was that the same as today? Was at first there was no change in the sugar and water? Or was it different? And as soon as we put it in the water, it started dissolving and changing. Right, it started changing immediately. So was there a difference to how much of the sugar cube dissolved? Yeah, absolutely, yes. Why do you think this is true? Well, because we had broken the particles into much smaller pieces, it gave more pieces for the water to act on. So let's come back to our snap cubes here. I'm going to put these together, and we're going to pretend like this block that I'm making, we're going to pretend like this block is a sugar cube, right? Like the first one we put in. Now, when we put this in water, the water was touching just the outside edges. So the water touched the top and the sides, and touched this side and touched this side. But the water could not reach what was in the sugar particles in the middle of this cube until it had dissolved away what's on the outside. So now that the water dissolved that piece of the cube away, now the water can access everything in here and start dissolving that. And then once it breaks away another piece, it'll start dissolving a new area that hasn't been touched by the water yet. But when we use that mortar and pestle, and when we broke all this sugar cube down into tiny little particles, the reason it happened so much faster is because in this state, the water could touch all the sides of each one of these particles immediately. The water didn't have to dissolve a piece away before it could get to a new layer. The water could dissolve all pieces immediately. That's why we saw such a quicker, such a faster dissolve rate with the crushed powder. So coming back to our paper, why do you think this is true? Well, this is true because the water was able to dissolve all of the tiny particles at once. Okay? All right, now we're going to go ahead and we're going to move down to, you can pause the video if you'd like to finish writing this. And you don't have to have exactly what I'm writing here. If you're making your own observations, that is perfectly okay. I support that. I think that's a great idea. You can write these, or you can write a different version of it if you want to, but you just want to make sure you have the general idea, right? So the general idea here is that yes, there was a difference, and the general idea is because the water was able to get to more of the particles. But you can word it your way if you'd like to. Definitely okay with that. All right, let's go to 8. This is our next sugar dissolving water that we're going to do. So we're going to observe the cube in warm water for 2 minutes. So the difference we're doing here is it's going to be a regular sugar cube, but we're using warm to hot water. Up until now, with all these other experiments, we've been using room temperature water. Now we're going to use warm water. So I actually have a tea kettle here that already has some hot water in it. Now this water might be a little too hot. I don't want it to melt my cup. So I have room temperature water in here. I'm just going to add this hot water to it. That way the water is hot, but not boiling hot. Okay? And now, and you can tell the water is still hot because it's creating this water vapor here. Remember we talked about change of state? The water I poured in there was turning from a liquid into a gas. This is turning into water vapor. It's starting to evaporate. So let's go ahead. I'm going to pour 100 milliliters in here. A little touch more. There we go. Now, let's watch closely because this might go by very quick. So here we go. Once again, you can see the water vapor on top of on the cup here. See that fog on the outside? All right, so we're going to do this for 2 minutes and begin. We can already see particles coming off. These particles are moving much faster. So the first thing we can observe is sugar particles coming off the top, floating to the surface. If you look over here, I can see, oh, there's a lot falling on this side. We can see the edges beginning to decay. That's happening right there too. Yep, see it falling off. So we're already getting a lot of observations. We're only About 30 or 40 seconds in right now, so this is going much, much quicker with the warm water. So our observations, the sugar cube is breaking down very rapidly. There are lots of sugar particles floating to the surface. There are lots of sugar particles falling off the cube and tumbling down. This is a very active dissolving. This is happening quickly. Why is this happening so quickly? Why is it happening quicker than the first time? Because of this warm water, right? Okay. So we're about 1.5 minutes. Look, and it's just dusted. Man, that warm water dusted that cube. Finished. Over. Destroyed. All right, let's take a look. We've got about 15 seconds left. Let's take a look at the top. Oh, man. Man, that's totally gone. I honestly thought there was going to be a lot more in there. You see this kind of hazy part right here? That is all that's left of our sugar. That's it. If we left it here, would that sugar slowly continue disappearing? Absolutely. It would definitely keep dissolving. All right, so that's our 2 minutes. Let's move this out. You want to get one more look at the side? Just gone. All you can really see is that small bit in the bottom of the cup here. All right, let's slide this out. Now we just have a couple questions. And then we're good for the day. So, number 8, observe the sugar cube in the warm water for 2 minutes. Record your observations below. So what did you see? Well, I saw that it dissolved very fast. I observed how much was left at the end of it. How much sugar was left in here afterwards? Very, very little, right? So we'll say very small amount left in cup. All right, because most of it dissolved away. All right, number 9, compare your observations of how the whole sugar cube dissolved at room temperature water and warm water. Was there a difference? So we're comparing what we just did with the very first time we did this experiment, where it was just a cube in regular water, no stirring, we just put it there and watched. So compare that first experiment to this one. Was there a difference? Well, heck yeah, there was a difference. That first one went super slow. This one went crazy fast. So, yes, there was a difference. Now I'm going to add one question here, and let's add a little bit about why. Well, the reason there was such a big difference is if you think back to our properties of matter unit, we learned that higher temperatures make molecules move faster, and lower temperatures make molecules move slower. That's why in the summer, if you go outside, it can be really slow and tedious opening and closing your hands, or in winter outside, it can be really difficult and slow opening and closing your hands because that cold weather is making the molecules in your hand move very slow. But in the summer, it's hot and we can move our hands quick. It's easy to move around because higher temperatures make molecules move faster, so your hand can move a lot quicker. And the same goes for this. On the first experiment with the room temperature water, the molecules were moving slower. But when we added this warm water, it made the molecules move much quicker, which caused, it made the molecules move much quicker, which made the water molecules hit the sugar a lot faster and break it off much, much quicker. So it didn't take any time at all. So was there a difference? Yes, there was. Why? because the higher temperature water made the molecules move much faster. Okay, now for number 10. This part's important. I'm not going to write your answer for you. I will talk about it, but you're going to have to come up with your own answer. I'll give you some examples and I'll give you some good information, but you'll actually have to take that information and make it into an answer. So, what conclusions can you draw about how shape, temperature, and stirring affect the dissolving rate of a sugar cube? So, remember, shape depends on when we had it in a cube and when we pulverized it as a powder. All right, so in a shape, how did the shape affect the dissolving rate? Well, the powder dissolved at a much faster rate. The powder dissolved at a much faster rate than the sugar cube. That's how the shape affected the dissolving rate. The powder dissolved much faster because the water could start dissolving all of the particles immediately instead of having to wait to break away some of the edge particles to get to the middle. All right, so a good answer would be something like the crushed up cube allowed the water to dissolve all the particles at the same time. All right, now temperature. How did the temperature affect the dissolving rate of the sugar cube? Well, again, the temperature made the dissolving process go much faster because the higher temperature made the molecules move a lot quicker. So they acted a lot faster in breaking apart the sugar molecules. The water molecules moved much faster, and so they were able to hit and tear away and dissolve those sugar particles much, much faster. And last, for stirring, well, it kind of works the same way as the temperature did. When we were stirring, we were creating a motion. We were making those molecules move even more by stirring it around. So stirring affected the dissolve rate because it created more motion and created more movement so that the particles struck each other much harder, and it was able to chip away at the sugar cube much faster. So all three of them increased the dissolving rate. The shape increased it because the water was able to dissolve all particles at the same time instead of having to wait. The temperature increased it because higher temperatures make molecules move faster, and so the water was able to move much, much quicker and start tearing away at those sugar cube particles. And the stirring made it faster because we were creating a motion. We were creating movement in the cup, and again, that made the water molecules move faster so that it could tear away our sugar particles much quicker. Feel free to back this video up if you want to talk about any more, if you want to hear me talk about any more of these answers. Because remember, I'm not writing anything here. This is for y'all to answer. And we do have to have this answered. So feel free to back up the video, listen to what we talked about. Feel free to look at any of our past from yesterday if you want to refresh on those. And tomorrow, for our next lesson, we will be making different Kool-Aid flavor. Oh, well, we'll be making lemonade of different concentrations and dilutions. So we will learn a little bit more about concentrated and diluted solutions tomorrow while we're making some Kool-Aid. All right, so guys, I appreciate your time today. Thank you.
Have a good day. See you, gang.